So first of all, the vector equation of the line BC, so it has to go either from B or from C, doesn't matter, because we want to go, here's the origin A, B, C. I want the line that's going through BC like this. So I need to get onto the line first, which is actually my vector B, and then I'll do BC is this vector here. I have to have a multiple of that to get anywhere down the line. So we need to find BC first, part A, BC equals, so that's C is 1, 3, 3, subtract OB to negative 1, 2, which gives me negative 1, 4, 1. Therefore, BC is R equals, let's use RB to negative 1, 2. Or I could have used my 1, 3, 3 because I could get onto it by going to C as well, that would work. Plus lambda lots of our direction vector 1, 4, 1. That's the vector equation lots. Part B, you determine whether or not the lines OA and BC intersect. Well, we need to find OA. So we've got OA, the line OA. I just need the vector OA. And to get onto it, I don't do anything. It's 0, 0, 0. So OA is R equals nothing. So that's 0, 0, 0 plus mu lots of, use a different variable because we've got a different multiple of 2, 1, negative 2, which is our OA. There's our OA, 2, 1, negative 2, so we get a multiple of that. And it says determine whether or not those two intersect. So to find out whether they intersect, we have to find 2, negative 1, 2 plus lambda lots of negative 1, 4, 1 equal mu lots of 2, 1, negative 2. So let's take the top two. We'll get 2 subtract lambda equals 2 mu. That means that lambda equals 2 mu subtract 2. And from the second one, that's our equation 1, equation 2. Negative 1 plus 4 lambda equals mu, and we'll put lambda into that. Gives us negative 1 plus 8 mu subtract 8 equals mu. That gives us 7 mu equals 9, mu equals 9 over 7. And we put that in the third option. Oh, we see what third option now. Oh no, we need to find out what lambda is. Lambda equals 18 over 7 subtract 14 over 7 equals 4 over 7. And we put that into 3, gives us 2. Lambda is plus 4 over 7 equals negative 18 over 7. So that implies that 14 plus 4 over 7 equals negative 18 over 7. Not true. Therefore, they do not intersect. Now we want the Cartesian equation of the plane that pi 1, which passes through C. So it has to go through C and perpendicular to OA. Well, to get a plane, I need the perpendicular vector. Well, if OA is the perpendicular vector, I've got the perpendicular vector, and it goes through C, so we can use that to find the equation of the plane. So therefore, we want R dot perpendicular vector perpendicular to 2, 1, negative 2 equals some value k. Substitute needs to go through C, so substitute 1, 3, 3, and we get R dot, 1, 3, 3 dotted with 2, 1, negative 2 equals 2 plus 3 subtract 6 equals negative 1. Therefore, this is pi 3, isn't it? So pi 1 is R dot 2, 1, 2, negative 2 equals negative 1. And did it want it in Cartesian? Cartesian, yes, so we need to put an x, y, z in here, which gives us 2x plus y subtract 2z equals -1. So that's pi 1 done. Part D, show the line BC lies in the plane pi 1. So BC, so BC, C lies in the plane, because we've already done that. Back here we showed that C lay in the plane to make that equation, so that works from part C. So now we need to show BC is in the plane. So to show it's in the plane, it needs to be perpendicular to the other vector. So if we've got here is the plane pi 1, we know the perpendicular here is to 1, -2. So if I can show that BC is somewhere in this plane, it needs to be perpendicular to this. So BC we've already calculated was -141. Dotted with 2, 1, -2 is -2 plus 4 subtract 2 equals 0. Therefore, this is BC dotted with 2, 1, -2. Therefore, BC is in the plane. Since it is perpendicular to 2, 1, -2. Therefore, BC is in the plane. We've shown that C, to start off with, we've got the origin here. C is actually in the plane, and the line that goes away from it, wherever it is going to be perpendicular to this, so it will stay in the plane at all times. Part E. The plane pi 2 contains OA and B, and the plane P3 contains OA and C. So first of all, plane P2, pi 2 has to contain OA and B. So therefore it's, I can find it, A and B are in the plane. So OA and OB are in the plane, so we need to find 2, 1, -2 crossed with 2, -1, 2, that's A and B. Gives us 2, 1, 2, -1. Will give us, first of all, to get the first part of the vector here, we choose these four, that's 2 subtract 2 is 0. And then this one is -4 subtract 4 is -8. And this one is -2 subtract 2 is -4. So it's perpendicular to. So therefore we show that 2j plus k equals, this is -1/4 times 0 and -8, -4. Therefore 2j plus k is perpendicular to pi 2. Find a vector perpendicular to pi 3, so that has to contain, now find a vector perpendicular to pi 3, and pi 3 contains OA and C, so it contains OA and C, and the plane has to be within that group. That means that OC and OA are both in the plane, so to find something perpendicular to both of those, I need the normal vector to those. So we need to do OA cross OC is 2, 1, -2 crossed with OC is 1, 3, 3, which is then 2, 1, 1, 3 is going to give us 3, so we get 3 plus 6 is 9. And then we get negative 2, subtract 6 is negative 8. And 6 subtract 1 is 5. So 9, negative 8, 5 is a perpendicular to plane 3. Plane 3 is this one, so 9, 8, negative 5. Find the acute angle between planes pi 2 and pi 3. So to find the acute angle between those, we need to do 9, negative 8, 5 dotted with, I could do the cross product as well, but the dot product's a lot easier. So the perpendicular is 0, 2, 1. Because I can take this one as perpendicular, as long as we're perpendicular, it's okay. Equals 0, subtract 16 plus 5 equals negative 11. Then we have the length of 9, negative 8, 5 equals square root of 81 plus 64 plus 25. That's the square root of 170. And then we need the length of 0 to 1 is 4 plus 1 square rooted, which is root 5. And therefore we have A dot B equals length of A, length of B, cosine theta. So cosine theta equals A dot B is negative 11 over length of A is root 170 and length of B is root 5. That implies that theta equals actually we don't need to do that because we just make this positive and it will give us immediately the cosine angle. So we do theta equals, and when you work it out, you put the positive value in your calculator, 67.8 degrees, which are 3 significant figures. Or I could do 1.18 radians. There's another way of doing it. You can get a number bigger than 100, bigger than 19, subtract it 100, you get the same answer, but the easiest way to do this, or for acute cosine theta equals positive 11 over root 170 root 5.